Hello everyone. In this video I want to talk about a little bit more advanced topics, two of them in GD&T: projected tolerance zone and dynamic tolerance zone. And dynamic tolerance zone is a new one that was added to 2018. So what are these? The projected tolerance zone is something that we use when we want to have two parts connected together using a fastener like a bolt or something, and want to make sure that when this fastener goes into the two parts, there is no interference. There is a clear mating, okay, between the parts, regardless of how thick the assembling part is. So it doesn't matter how thick this part is, whether it's this thick or this thick or this thick, okay? Still, make sure this part can go in and the assembly can be done. And you might say, well, does it matter how thick? Yes. Because if you look here there is a little bit of, again, exaggeration, but the drilling is done with a little bit tilt, okay? So the axis here of the bolt is not 100% perpendicular to these horizontal planes of the parts. And when that happens, if you look here, so here is the tolerance zone that I have for the position of the axis of the hole. So here, this axis here, right, this cylindrical surface, it had some position tolerance zone, right? And this is this small green cylinder, which forces the axis of your bolt to be within the cylinder. And you see it is right now. Look here, you see it's inside of it. The problem is, you see in the bottom part it's okay, but once the bolt is compared against the top part, here in this region you have overlap, you have interference, and that physically is not possible. So now if this top part, this part 2 on the top, was thicker, right, so it was like this thick, and then this interference would have been more serious, because now your interference would be something like this. Okay, so you have more interference now because the part is thicker, because that tilt over a larger distance will create more interference. So here the goal of this projected tolerance zone is to make sure that regardless of how thick this top mating part is, still this bolt can go in, can do the job, and can do the assembly without any interference. And how would you do that? By bringing this tolerance zone from down here on the bottom part, projecting it onto the region above the middle part, the bottom part, and bringing it up here. So projecting it onto this top part, as you can see, above the hole, projecting it above this threaded hole, because the thread is happening here, okay? This is where the thread is. So you bring the tolerance zone projected above the threaded area, you bring it up. Now when you bring it up, what happens is, if you look at this green cylinder, it is the same size as the previous one. We have not increased the size. We have not increased basically this value, whatever that we put in here, whatever number it is. We kept it the same, but we just brought it up. When we brought it up, it forces the tilt of the bolt to be less, right? Because now if you look at this angle, if you look at the angle of this line versus the angle of this one, you see it's smaller. Okay, so by projecting it above the threaded area, we forced the angle of the tilt to be closer to 90 degrees. And how far is this tolerance zone active? In other words, this part of the axis of the bolt that has to lie within this green tolerance zone, right? How tall is this tolerance zone? You have to specify that. So you have to say, what is this height of this tolerance zone? What is the amount of projection? And the rule of thumb is it should be at least equal to what? Equal to this thickness, to make sure that there is no interference. Okay, so that is the overall idea of a projected tolerance zone. So you see here I said that the projected tolerance zone height should be at least equal to the maximum thickness of the mating part. Okay, now how would you show that in GD&T? Look here. So when I want to show the position tolerance for the center of this bolt, I provide the amount of it. You might or might not have an MMC, but the thing that I add is this part. Look, I say projected, I use a P and then 14, and 14 is this height that you need to bring up that tolerance zone, the cylindrical tolerance zone, above the threaded area, and put the axis inside that in that region. So you need to add the height of that as well as what? As well as this projection right next to the value of the tolerance zone, so they know how to inspect it. Now, the other thing we have is, you might say, under what condition should I use this projected tolerance zone, right? For what scenarios? And here it says there are two scenarios that you might consider to add a tolerance zone, a projected tolerance zone. First is when the mating part with a clearance hole, pay attention, this is about the clearance hole, has a thickness greater than the diameter of the bolt or the pin to be used. Second, the thickness of the mating part is greater than the thickness of the bottom part. Okay, so if you look at this scenario that we have up here, the thickness of the mating part, which is the top part, is not greater than the bottom part. Okay, it's less than that, but that is more than the diameter of this bolt. So as long as the diameter, the thickness of this top part is more than the diameter of the bolt or more than the thickness of the bottom part, you want to use a what? You want to use a projected tolerance zone. And let me show you how to do that in SolidWorks. So here I have added it here, but I'm going to do it one more time for you so you see it. So this is the threaded hole, and I have added a hole call out for it, so it shows the information about the diameter of the machine and the depth of it, and then everything else, right? And then here you see I have added that P and 20 here. Now in SolidWorks it adds that MMC. If you want MMC, it adds it after P20, not before P20. Okay, so just be aware of that. So it's not going to do it exactly like this. It brings the M on the other side, but it's not a big deal. So let me show you how to do that here. So here I use a hole call out and I apply it to this threaded machine hole, right? So you see all the information about it. Again, the top part is for the machine hole, the bottom part is for the thread, the tolerance of the dimension of the thread, and the depth of the thread. Now I want to add a position tolerance for the center of this hole. So here, look, I want to add a geometric dimensioning here. So I select that and go there. And you see here, it is added to the bottom of that already. And now I'm ready to add the information. So I double click here, and now I'm ready to double click and start adding the dimension. So what I want is a position tolerance, and let's say 0.005, right, 5,000, and it's a cylindrical zone. And now if you want, you can go to what? To material condition and say this is MMC. You can add that. And now to add that projected, you go to feature, and you see here it says derived feature. You click on P, and then it gives you a place to put the dimension. So let's say in this case, the thickness of the part that is going to sit on this part is 20 mil. So I added 20 and done. And there we go. Look, you see? So you see that is added. And now, of course, you have to add datums, right? So you double click, go back here, and you need to add datums, right? So you say add datums, and then let's say you added with respect to datums A, B, and C, because it's a position tolerance, and now it's done. So again, as you can see here, it brings that MMC instead of right after the dimension, it brings it at the end, but the idea is the same. You can read that. This is projected 20, and then MMC is for the size of the tolerance zone. Okay, so this is how you do what? You add a projected tolerance zone. The next topic is called, as I said, dynamic tolerance zone, which is a new topic in 2018 in ASME GD&T for 2018 that was published. And the idea is this. So here, let's say this is a hole, a pocket, and I need to control the shape and the size of this pocket. So what I do is I put a profile here. As you can see, I put a profile and I give it 2 mil offsets, right? One on each side of the true profile with respect to ABC. So if you look at it in this window on the right, this is the true profile, right? It's actually in the middle, it's not shown, and 2 mil is on both sides of it, okay? So in this case, you have a profile, right? Which again, it's not shown in here, but if you want, we can add that. So let's say something like this in green. And then 1 mil to the left and right of it are the allowed tolerance, right? Tolerance zone. Okay. So that's because I can have room for a little bit bigger or smaller hole. I don't want to make it super tight. That's why I gave it a very loose tolerance. But the thing that I need to pay attention to is any shape of profile inside this 2 mil wide tolerance zone is allowed. So if instead of this green profile or something similar to that, I have this red profile, and let me get rid of this green thing that I did. If a machinist give me something like this red profile, it is still acceptable. The problem is the shape of this red profile is not similar to the intended profile. I mean, it's not just it's off, the shape has changed, right? It has corners where it shouldn't. Instead of here and here, it has the corner up there, plus all of these big rough areas, right? And lots of ups and downs and non-flat areas. So is this acceptable? Yes, based on just the profile, yes, absolutely it is. Now you might say, how can I improve that? Well, go ahead and change that 2 to a very small thing, so make it 0.02. Now you don't have too much wiggle room because the profile controls the form as well. But now you are making it so tight, well, you shouldn't really necessarily make it that tight. What you cared about was keeping the form without restraining the size too much. So the goal is not to tighten the size too much, yet still asking the technician to what? To preserve the form for you. That's where you add this dynamic tolerance zone at the bottom of the profile. So you add a secondary profile, this time with the tighter tolerance zone, and you add this dynamic, you add this delta symbol. What does that mean? It means, hey, I now have a secondary tolerance zone that the thickness of it is only 0.4, and the profile you give me should stay inside of this 0.04, but to relieve that and not completely eliminate that 2 mil wide profile, to still preserve that, I allow this tight tolerance zone to be able to what? To be able to expand, contract, rotate, and translate, as long as it stays within what? Within that 2 mil wide tolerance zone. So this narrow band can be what? Can be a little bit bigger. It can rotate, it can go up and down, it's dynamic, it can have a free motion, as long as it stays inside the bigger region, right? So you see, the technician has now freedom to change the size, and if not, I mean, like, not intentionally, but if they made it a little bit bigger or smaller, or it's a little bit tilted, it is still okay, as long as it's within the 2 mil wide tolerance zone. Yet they cannot really change the form big time, so they are constrained to keep the form for you. In terms of form, they have a much tighter tolerance zone, but in terms of the size, they have a bigger tolerance zone. So this way you allow for size modifications, but you are preserving the form. So that's why you always add this dynamic tolerance zone as a secondary tolerance zone to a profile tolerance zone, okay? And here, to give you an analogy, remember that when we had a cylinder, a shaft, and we wanted to make it, we gave it some bigger tolerance on the size, right? So this size plus and minus 0.3, that controlled the form and the size, but we kept it a little bit loose because the size was not as critical, but to make sure that the shape of the profile is a circle and the shape at the end looks like a cylinder, we could add a cylindricity constraint with a tighter tolerance zone. So now you have two constraints, one a little bit looser on the size and the other one a little bit tighter on the form, okay? So the cylindricity was just controlling the form. And so you can do a similar thing here. If the profile like is a hexagon or anything else, or like this shape here, then you can have a looser profile tolerance zone, right, to control the size, and a tighter one with a dynamic to only control what? The form. So these two are basically similar to each other. While cylindricity was only for a circle, this dynamic plus profile is for any shape, not just the circle, right? And if you want, you can have it all around the shape or just in a portion of it. So how would you do it in SolidWorks? So here, I have done it here, but I'll do it one more time for you so you can see that. So I go ahead and apply a profile here, right? So I say I want this to be profile, and then like I make it 0.3, right? And then of course with respect to A, B, and C, so let's go ahead and add those, right? Something like this. And of course you need to add this all around, okay? So here is the looser tolerance zone all around the profile. Now you can add a bottom frame here. You can add a bottom frame, and in that you add the triangle. Now if you click on this, double click, this bottom one allows you to either add a new frame or a below frame. If you add a new frame, what's the problem? So it gives you the profile, it gives you this tighter tolerance zone, and if you want, right, you can double click here and change that number. So let's say, for example, this is 0.08 or something like that. Okay, the problem you have here is when you want to add that delta, right? When you want to add that delta here in this window, there is no delta. So if you look at the offset, there is no delta. If you look under features, again, as you can see, I mean, at least I cannot see any delta. Under characteristics, I cannot see delta. Material condition, of course not. And then under symbol, there is nothing. Okay, so it does not allow you to do that. Okay, so this below frame, it does not allow for it. So I need to get rid of this one and add a new one here. And for that, now look, the other thing I can do is click here, and instead of new frame, say below frame. And here, below frame, you can insert the symbol of the profile, right? So you go to geometric tolerancing, add a profile, and then let's say add that 0.08, right? And here, you should be able to go under modifying symbols and add the delta, right? You can add the delta and OK that. So now you have all of the things that you wanted, except that they are not in a frame. They are not inside this box with separating walls, right? And by the way, the name of this delta, as you can see, is mode delta. So look what I do here. I copy this so I have it. And here, if I click here and say new frame, of course, it's going to create a new frame, but below this one, okay? So I can say, hey, add a new frame for me, and it does. The problem is this one, as I showed you, it doesn't have the location for delta. So what the only trick to do is now I get rid of this bottom one, okay? I don't want that. I go back to that, and the only place that you can add it is what? Is under datum. So I go add a datum, and instead of A, I paste that term that was mode delta, and I say done. Look, now you can have it the way you want it. Okay, so I add a new frame, but I copy that name delta, right? And then you add it as a datum for this bottom one. And this is how you do it. I looked all over the internet for a better solution than to just add it in the location of datum, but I couldn't, and maybe it's appropriate to add it under datum. So anyways, this is how you add a dynamic tolerance zone as well as a projected one, and hopefully the video was useful to you. So I'll see you in the next lecture. Thank you.